The angular speed of a body changes from omega 1 to omega 2 due to changes in the moment of inertia without applying torque. The ratio of radius of gyration in the two cases is. Alright, so what is happening? Without the application of torque, the angular velocity is changing. Okay, so if there is no external torque, what do we know? We know that the angular momentum of the system is going to be conserved. Okay, so can I say the initial angular momentum has to be equal to the final angular momentum? Simple. Okay, now if the angular velocity is changing, angular momentum is given by I into omega. So if omega is changing and L is remaining constant, it clearly means that I is also going to change. Okay, so let's say that the moment of inertia in the initial condition is mk1 square. Okay, so moment of inertia I'm writing in terms of radius of gyration, and that becomes mk1 square multiplied by omega 1 is equal to the final angular momentum is going to be mk2 square, where k2 is the radius of gyration in the final scenario, multiplied by omega 2. All right, so m gets cancelled, and what do I need? I need k1 upon k2, and that is going to become omega 2 upon omega 1 under root. So obviously the correct option is going to be omega 2 under root is to omega 1 under root. All right, let's have a look at the options. So option B is going to be the right answer. If a solid sphere of mass 1 kg and radius 0.1 meter rolls without slipping at a uniform velocity of 1 meter per second along a straight line on a horizontal floor, then its kinetic energy is. All right, two important things. It is rolling without slipping, very important information, and we have to find out what is the kinetic energy of this body. Okay, and what is it? It is a solid sphere. Perfect. Now, in case of rotation plus translation, how do we find the kinetic energy? We find the kinetic energy by adding two terms. What are those two terms? One is the kinetic energy of the body about the center of mass, and that is half I cm omega square, correct? Plus the kinetic energy of the center of mass, which is half m v cm square. All right, and we know both the things, so we just have to substitute and find the answer. So let's do that. So half into ICM, it is a solid sphere, so this is 2 by 5 mr square. Okay, we have not been given omega, but we have been given v, and we have been given it is rolling without slipping, which means v has to be equal to omega r, and omega has to be equal to v upon r. All right, so for omega, can I substitute v by r? So this becomes v square by r square plus half m, and what is vcm? Vcm is this quantity multiplied by v square. Is that correct? So what are the things that get cancelled? R square from here and r square from here are gone, and then I have half, and then I can take common mv square, so I'm left with 2 by 5 plus 1, and this is going to become half into 7 upon 5 mv square, so this becomes 7 upon 2 mv square. Now all we have to do is do the substitution. So 7 by 10 into 1 square is going to give me how much? It is going to give me 7 by 10 joule, and that is the total kinetic energy. Now let's have a look at the options. So option C is going to be the correct option. When a uniform solid sphere and a disk of the same mass and of the same radius rolls down without slipping on an inclined plane from rest to the same distance along the inclined plane, then the ratio of the time taken by solid sphere and the disk to cover the distance is. Okay, so we have a solid sphere and a disk. They have the same mass, they have the same radius, and they are rolling without slipping. Also, they start from the same point with zero velocity and roll down the inclined plane and cover the same distance. We need to find out what is the ratio of the time taken to roll down. Okay, now in order to find time, obviously we'll have to use kinematics. So let's say this distance is x, okay, the distance along the inclined plane, and let's say their acceleration is a along the inclined plane. So can I say x is equal to ut plus half at square? Absolutely, I can say that. Now initial velocity is 0, so this is going to give me T is equal to 2x upon A under root. Now x is same for both the particles or both the objects. So can I say that the time taken is inversely proportional to 1 upon the acceleration in the direction of or along the inclined plane? Is that correct? So all boils down to finding the acceleration and comparing the accelerations. Okay. Now for an object which is rolling along the inclined plane, we have a standard result for acceleration. And what is that? That is g sine theta divided by 1 plus k square upon r square, where k is the radius of gyration. Now g sine theta is a constant. So acceleration is inversely proportional to 1 plus k square upon r square. So can I say that time taken will be directly proportional to the under root of 1 plus k square upon r square? Alright, that is the relationship. So I can say that T1 upon T2 is going to be equal to under root of 1 plus k1 square upon r1 square divided by 1 plus k2 square upon r2 square. Now what is k1? K1 is the radius of gyration of the solid sphere and k2 is the radius of gyration of the disk. Okay, so let's find out what is this k1 square upon r1 square. Now the moment of inertia of a solid sphere is 2 by 5 mr square. Is that correct? Can I equate this with mk1 square? Of course I can. So m gets cancelled and k1 square upon r1 square is 2 upon 5. We can see that very clearly. Also, the moment of inertia of a disk is mr square by 2, and can I equate it with m into k2 square, where k2 is the radius of gyration of the disk. So from here m gets cancelled and what do I have? I have k2 square upon r2 square, or k2 square upon r square is equal to half. Alright, so I have found out both the values. Now all I have to do is substitute. So this becomes under root of 1 plus k1 square upon r1 square is 2 by 5. And then this is under root of 1 plus k2 square upon r2 square is half. So this is going to be how much? This is going to be 7 by 5 under root multiplied by 2 upon 3 under root, and finally I'm going to get under root of 14 is to under root of 15, and that is going to be my answer. Alright, let's have a look at the options. So option C is going to be the right option. The question is, the load versus elongation graph for 4 wires of the same length and the same material is shown in the figure. The thinnest wire is represented by, okay, so we have a graph of load versus elongation. So load is basically the force which is being applied on the wire, and elongation, let's call it delta L, is the elongation of the wire. Now all the wires are made up of the same material, which means they will have the same Young's modulus, and all of them have the same length. Okay, so we need to find out which of these 4 wires is going to be the thinnest. How do we decide thinnest? We decide thinnest by area of cross section. All right, so Y is equal to the stress, which is force upon area, divided by the strain, which is delta L upon L. Okay, so I can rewrite it as F upon delta L is equal to YA upon L. Now why I have written F upon delta L? Because that is the graph I have. Okay, and if I take the ratio of F and delta L, what does it give me? All of these lines are passing through the origin. So F by delta L is given by the slope of the line. Is that correct? Okay, so the slope of the line is basically given by YA upon L. Now all of them have the same Young's modulus, so this is a constant. They have the same length, so this is a constant as well. So what we see is that the slope of this curve is proportional to area of cross section. So if a wire has larger slope, it will have larger area of cross section, and vice versa. So we need to find out which one is the thinnest wire, which means which one has the lowest or smallest area of cross section. Hence the wire for which F upon delta L slope is the minimum is going to have the thinnest cross section. Okay, so the thinnest wire is going to become OA. All right, and that should be my option. So option C, OA, is going to be the correct option. The question is, the approximate depth of an ocean is 3500 meter. The compressibility of water is 50 into 10 to the power minus 11 per Pascal, and the density of water is 10 to the power 3 kg per meter cube. Find the fractional compression of water that will be obtained at the bottom of the ocean. Okay, so we have an ocean, and the depth of the ocean is 3500 meter. Okay, so the water at this point and the water at this point are going to be at different pressures. So as we go down, the pressure is going to increase, and hence there will be compression in water. So we need to find out what is this fractional compression. Now the fractional compression and the excess pressure is related by the relationship the bulk modulus is equal to delta P divided by minus delta V by V. So from here we can say minus delta V by V, or the fractional change in volume, is equal to delta P divided by the bulk modulus. But we have not been given bulk modulus, we have been given compressibility. And the relationship between bulk modulus and compressibility is K is equal to 1 by B. So I can substitute K for B, and I'm going to get delta P multiplied by K. Now what is this delta P? When we are going from this point to this point, the pressure is increasing by an amount delta P. And what is that amount going to be? It's very obvious. That amount is going to be rho GH. Is that correct? Delta P will be equal to rho GH when we are going from here to here. Okay. Hence the fractional change in volume minus delta V upon V will be equal to delta P, which is rho GH multiplied by K. Now all I have to do is do the substitution. Okay. So let's do that quickly. So this becomes rho 10 to the power 3, G is 10, H is 3500, and K is 50 into 10 to the power minus 11. Okay, what are the things that go away? So this is 3, this is 4, this is 2, 6, and these are 7 zeros. So this becomes 10 to the power minus 4. And what do we have? We have 35 into 5. So 25, 2, 15, 175 into 10 to the power minus 4. And finally, I'm going to get 1.75 into 10 to the power minus 2. This is the fractional compression. And that should be my answer. Now let's have a look at the options. So option C is going to be the right answer.